Hello guys, Assalamualaikum. This is instrumentation, measurement and instrumentation, SKMM, SKMM3242. We are now looking at lecture 2, which is based on analog and digital transfer function and data analysis. All right, let me go through the PowerPoint slides. Okay, you can find the PowerPoint slides. I'm going to share this thing to you. Okay, hold on a second. Okay, here you go. I hope everybody can see this. So again, this is lecture 2. We are looking at the analog and digital transfer function and data analysis in the topic of instrumentation. All right, so from the previous lectures, I've mentioned that the whole subject or the whole syllabus is very much easily can be divided into 3 different sections. The first part is basically on the theoretical part, the introductory to, you know, we learn about the basics of system of instrumentation. We learn the basics of the basic building blocks of system of instrumentation. We learn about this analog and digital transfer function, how to analyze the data when you receive the data from the system of instrumentation. And later on, we will see how do we quantify the data, how do we see the system performance, how do we calculate the system error and everything. So the whole section 1 will be about, how we'll be discussing about the basic building block of system of instrumentation, data analysis and transfer, and performance measurement, basically, right? So that's the first one. The second part will be looking at the signal conditioning system. We will be looking at circuits. We will be looking at operational amplifiers, filters, many other signal conditioner circuits. That's the second part, and the third part we'll be looking straight to the design and construction of several sensors. All right, for example, we have capacitive, inductive, we have accelerometer, we have many other things. All right. So again, now we are still in the section 1, looking at lecture 2. This is the very basic of analog and digital, and how the basic things works here. So this is the very basic introduction of instrumentation components. Can be in the form of analog and digital. Right. Previously, decades ago, most of the system of instrumentations are in analog form because the digital form is not being invented yet. Right. But today we have more digital than the analog. We have a lot of sensors from the analog world now being converted to digital world because of several issues. The most important one is calibration and accuracy. All right. So on the slide that we have example of digital and analog system. For example, for the digital one, we have absolute shaft encoder, and for the analog one, we have a tachometer. Okay, we will go further on this thing later on. All right, because of course, when you speak about analog system, analog sensors, analog actuators, you are talking about a wide variety of voltage range. Depending on the operational voltage for that system. For example, if you are working with a system which the operational voltage is 5 volts, then you can see the analog signaling will be spanning from 0 to 5 volts. All right, it can be 3 volt, it can be 2.9 volt, it can be 4.2 volt. You can take any volt from 0 to 5 because the system is working in analog mode, and the signaling, the information is drifting from 0 volt to the maximum operational voltage, system operational voltage, which is 5 volt. All right. In the digital system, basically, digital, you are looking at either on or off, either 0 or 1. So the high or low. All right. So if the system is basically working in digital mode, okay, the low logic, the zero logic, the uh, the activated logic will take 0 volts, and the activated logic or 1 or high will take 5 volt, and you have only these two states, which is 0 and 1, low or high, 0 or 1, 0 volt or 5 volt. All right. So the system will be giving only these two outputs. All right. 0 or 1. Okay. Compared to the analog system, they can give any voltage from 0 to 5 volts. All right. So that's the difference between analog system and digital system in instrumentation. And now, basically, when we speak about system of instrumentation, we are speaking about a system which receive input and a system which, when you have input, you are putting out something. So we are looking at the output also, right? But in order to properly characterize a system of instrumentation, we need to know what's the input, we need to know what's the output, right? So in the blacks, in the box, as you can see from the slide, you may have some system of instrumentation processing the input so that the output can be, translate or transform in some manner, basically. All right. So in the diagram, you are seeing the U as the input, Y as the output, and then there's something in the box that change the U so that you can get Y in the output. All right. So basically, it's a function, it's a mathematical function, it's a mathematical model that basically works in the function of U, Y, and of course over the time. All right. So you have two things here. If you talk about system of instrumentation, you have the static part and you have the dynamic part. Okay, the static part states the relationship between input and output when the input is not changing with time. All right, and then you have the dynamic part in which uh, you know the input change over time, and to do this you have to work with differential equation. Okay, again you have static part, the input is not changed with time. If for example like a switch, so you will be you turn it on, you have high all the time regardless of the time, whether you switch it late or early, you still receive the same logic, high or low. Okay, and for the dynamic part, the system that react differently in different time. For example, your elevator, your your kettle boiler, for example, you switch on the switch for your boiler for your kettle, you won't have the temperature rising straight to 100, so you have to wait. So the input is basically changing over the time. So that is dynamic part, and in order to characterize that properly, you have to work with differential equation. Okay, for example, then the relationship between temperature T and voltage V is given by V equal to 0.005 T, and this equation basically relates between T and V by a constant of 0.005. Okay, so there is no time term in this equation. You have voltage and T is a temperature, so there's no time, meaning that in any given time, in any given days, month or year, this equation still hold. When you give that particular temperature, you will have that particular voltage output straight away. Okay, there is no time, what they call that, influence in this static system in that case. All right. This is another example that you may want to to look into. This is I think you must see this, because normally in the exam this is the most popular question they will ask basically. So you have temperature range of 20 to 120, and then the keyword here is linearly converted. Okay, standard current of 4 to 20. What current will result from 66 degree, and what temperature does 6.5 milliamps. All right, so you have two information linearly related, so you have to solve what they call that a linear equation, because it says from the question it is linearly converted, so you have to work on linear equation from given these two parameters, and you have to write these two equations, enter all the known variables, and start to find the unknown variables, and you will come to the last equation, and you can find this 6.5 milliamp and 66 degrees Celsius. What does it correspond to? All right. Okay. From the previous example, we are looking at the voltage signal and current signal. Okay, so as a standard form, basically current signal is ranging from 4 to 20 milliamp. So normally they use a voltage to transfer information. Okay, because from one sensor you need to transfer your readings to the next system. So typically they use voltage as a medium of transfer. For example, 2 volts mean like 7 degrees Celsius. 5 volt meaning can take the meaning of 50 degrees Celsius. All right. So, but in some other situation, instead of using voltage, they can use current. Okay. But as a standard form, the current only take from 4 to 20 milliamps, and in order to do this, you have to have some kind of translation circuit to translate these ranges of current from 4 to 20 into range of voltage, because typically the system will read voltage more than the current. Okay, all right. So that's the current signal, and below down there is pneumatic signal. It's working in that range. All right. Okay, you can see from the diagram, the left part is the sensor that sends current, that send current to the control room. Okay, the left part is the plant in which you have sensors and valve. The right side you have control room. All right, if you look at the left side, the sensor is sending information in terms of current. Okay, so you have 4 to 20 milliamp on the line, and in the control room side, you have to have this I to V conversion, current to voltage conversion, because most of the system reads in voltage, works in voltage. So conversion to current here is essential just for transmission system. Okay, the same thing goes to the pneumatic. You have valve, you have some kind of actuator which convert and regulate the pressure into the range, into the transmission or information transfer range, which is from 0 to 15 psi. And then you have to convert this thing again. All right. I'm gonna pass this. Okay, this one is let me. Okay, after this we are going to look at the slide on data analysis, significance and characteristics. Okay, just now we were just looking at the very basics of system of instrumentation, analog and digital. We just look at transfer function, and now we are looking at the significance and statistics. I believe most of you have learned this thing from your, previous level of education. We will be looking at mean deviation, variance, and standard deviation. I think you have seen this. I'm not going to go through in detail. There is also no specific exam question with regard to this section. Okay, I will just go through. You know what to do. The definition of all this thing is the same thing as you have seen in the previous lectures. Basically, you know how to find the mean, median, variance, and standard deviation. So I think that's all for this particular topic. See you again in the next topic. Goodbye.